Good morning and welcome to today's lesson on surface area of prisms. This is the second such lesson. The first one we really saw the formula, we broke down how the formula came to be. Now we're going to look at some other forms of prisms. Specifically, I want to look at a triangular prism. So I have here a 3-ring binder, which most people are looking at it going, that's a prism? Sort of is. If you think about it from a, what it's its shape. Okay, if we look directly at it, I can see very clearly it's a triangle, right? One, and then we got flat, we got and then back up. Okay, so if I were to draw this triangle on the board here, it would look something like this. And that's a terrible drawing, and not even a good pen. Just throw that one over there. So there's that triangle we saw in the front, and then it kind of goes all the way to the back. So there's the triangle in the back, and then we can dot it all the way to the front. So we can see that there is a triangle here in the front, and there's a triangle, oops, here in the back. And they're the same. They have to be the same for us to have a prism. Remember, that was the definition, is they have to be two bases. They have to be congruent. I should have said that. I'm not even sure I said it in the last video. So let's say it now. They have to be the same. Okay, you can't have like a big one and a little one. That'll be some other shape that we're not dealing with right now. That's not a prism. Okay, the bases have to be exactly the same. Okay, whatever your shape is. So if you've got a triangular prism, then both the triangles have to be the same. Okay, they have to be congruent. But if you recall, we had a formula for finding the surface area. It was 2, whoops, that's a 3. I'm gonna have one of those days. 2 base area. So we have to find the area of the base. We're gonna have to find the area of this triangle. So I'm gonna need some measurements. I'll come up with those in just a moment. And then we need the perimeter of the base. So again, I'm gonna need some more. And then we need the height of the prism. Okay? So we need a B, we need a P, we need an H, so we can plug them into this formula. And I tend to like to organize them this way, because once you start getting into this habit, all prisms basically break down into these 3 pieces. It also really helps when we get into volume, because you're only going to need those 2 pieces for that. We'll talk about that more a little later. So I'm going to need to know a little more about this triangle here in the front. So here's my triangle again. I'm going to need, let's make this 8 feet. We're going to make these 6 feet. Oh, let's make it easy on ourselves. We'll make it parallel. And then we need a height of the triangle. We're going to make that one 5 feet. This is where things get really confusing. So let me take a moment here. Because now we have 2 different heights. And for both of them, we would use a lowercase h. One of them is the height of the prism. And that's going to be this value right here. I'm going to make that one 10 feet. The other one is the height of the triangular base. So there's the height of the base, and then there's the height of the prism. And they are never the same. They may have the same value once in a blue moon, but they are never the same measurement. Meaning, if I go back to showing you my triangular base, this would be the height of the base from here, just right to the center of the bottom. And this would be the height of the prism from one base to the other base. Remember, that's the height. That's how the prism's height is measured, from base to base. So the prism height, let me write that down. Prism height, gosh, I'm just doing myself a disservice. And you guys. Prism height is measured from base, I'm going to use capital here, base to base at a right angle. And if you go back and look, so it's when it hits, this is a 90-degree angle. You can see that because this is the height of the prism hitting the base of the prism right there, nice 90-degree angle, you can see it. And that comes into play when we talk about something called an oblique prism, which I'll draw for you in just a moment. Okay, but let's go back to this one. So now we have ourselves a triangle. So we need its area, we need its perimeter. The height, we just grab right off the drawing. There's really nothing for us to do. 10 feet. No calculations to be done. Okay. It's not the 5. 5 is the height of the base. So now we find the area of the base. Well, triangles are 1/2. See, remember we talked about why I said I'm going to use the capital B and why it's going to be different, and we're going to see a lowercase b? Here it is. When you want to find the area of a triangle, it's 1/2 base times height. And both of those are lowercase, and they specifically refer to the triangle. The capital B refers to the whole shape. The lowercase b refers to just this part that meets the right angle with the height. So 1/2 of 8 feet times 5 feet. 8 times 5 is 40. Half of that is 20, and these are square feet. And then the perimeter just wants around the outside. 6 plus 8 plus 6, that's 20 as well. But that's singular feet, because we're going to multiply it times the other singular feet, the 10 feet. And now we can find the surface area of the whole thing. I'm not sure you can see it, but here we go. So surface area equals 2 times 20 feet squared plus 20 feet times 10 feet. So 40 feet squared plus 200 feet squared is 240 feet squared, or square feet, depending on your preference. They mean the same thing to say square feet or feet squared, so it does not distinguish one from the other. Okay. And again, this is not an easy process. It's not a quick process, because you're finding the area of 5 shapes all at once. Oh, and I wanted to show you something. We talked about the base, right? The base is this nice little triangle. But what are the other 3 sides? Look at this. If we unfold it, what do we got? Rectangle, little rectangle, rectangle. So we have 2 rectangles, or 3 rectangles, excuse me. Rectangle, rectangle, rectangle. So we have 3 sides. So we have a triangle. We have 2 of those, the front and the back. And then we have 3 rectangles. So that's why every prism, all the other sides are rectangles. The base, and look, I just tore off the label. The base may be the triangle, but the rest of the sides are rectangles. Okay. We use the exact same formula regardless of what the shape of the base was. The base happened to be a triangle in this case. If the base was a pentagon, an octagon, a trapezoid, we'd still use the same formula. The thing that would change is, how do you find the area? In the first video, we showed you finding the area using a rectangle, length times width. Here we had a triangle, which was base area, which was length times width divided by 2. And sometimes you need more measurements, because the shape, to find a triangle, you need to know what the length and the width are. And notice again that it doesn't have to be sitting like this. We don't have to say the base is the thing it's sitting on. We can face it towards you. I could turn it this way. It doesn't make any difference. The base is the triangle, because this is a triangular prism. Okay? Now, I'm going to show you one more prism, and then the next lesson, the next video will be all about cylinders. Okay? And that is, again, not the greatest artist, so I'm going to have to do what I can do. So we're going to do a little rectangle, and then we're going to do this weird, like, kind of looks like a trapezoid to me. See if I can do this a little bit better. I know what to do. We're going to draw ourselves a little rectangle here, and then we're going to draw ourselves a little rectangle here, and we're just going to connect the corners. Now it may look like it's coming forward here, but what I'm trying to demonstrate is something called an oblique, which is to say it's not, they're not right on top of each other. They're, instead of the bases being like this, the bases are like this. We would still want to know the height, and we would measure the height outside of the shape. That's what makes this a little weird. The height of the prism is measured outside. Think of taking like a slinky or something, and instead of having it be right on top, just pull it this way. We would still want this distance. Even though they're apart from each other at that angle, we want to know this distance straight up and down, or straight forward and back, however you want to do it. And I apologize for my lack of artistic talent here, but an oblique prism, again, means, in fact, it comes from, we use the word oblique all the time. The obliques are this muscle right here. They're the ones that make you lean. So if you think about it, it's like the shape is leaning. It's like saying, how tall are you? And then you go, well, I don't know, how tall am I now? It's like, well, no, we don't care that you're leaning. All I care about is how tall you normally are. Well, how tall is this shape? Well, even though it's leaning, I want to know if we were to stand it back up, what would it be its height? And that's why we would measure the height of the object outside of the shape. Okay? So this is what we would do for an oblique prism, regardless of what type of prism. So that's another adjective we can use to describe it. So we would refer, so this would be an oblique, and this is how you spell it, O-B-L-I-Q-U-E, oblique rectangular prism. So each one of these things tells me something about the shape. So oblique tells me that it's leaning, rectangular tells me the bases are both rectangles, and a prism tells me that the other four sides have to also be rectangles. So it tells me a lot by just naming it. So oftentimes one of the questions I like to ask students is, what do you call the object that we're looking at? So if you're staring at it, you go, well, what is it? You say, well, it's a rectangular prism. It's a triangular prism. It's a hexagonal prism. It's a... As soon as you start calling it things, you're telling me about some of its features. You say it's a trapezoidal prism. You've told me the bases are both trapezoids. You've told me because it's a prism, they have to be equal. And because it's a prism, the other four sides have to also be rectangles. So you've told me a ton of information simply by giving me the name of the object. Okay, so it's important that we understand what it is when we're naming these things later on. If you tell me it's oblique, you're telling me that it's leaning over. Okay, so now you're telling me more things about how the shape should look and how we would measure its various properties. But again, we would still use this formula for finding the surface area. So again, one more time, we need the base area. We need the perimeter of the base, and we need the height of the prism. Like I said, in the triangular one that we just saw, we needed the height of the base to find its area, and then we needed the height of the prism to find the surface area of the whole thing. So we needed two different things that we call height. It's always a problem when you have the same word describing two different parts of a big object. We need two different heights, height of the base and the height of the prism, and they are never the same. They may have the same value by some weird coincidence, but they are never the same values on the drawing, on the graph, on the whatever you're looking at, whatever the picture you're dealing with. Okay, height of the prism we're always going to need for both surface area and eventually for volume. The height of the base we pretty much only need if the base is a triangular base. It's the only time we need it, really. Well, that's not true. If the base were a trapezoid, we'd also need the height. There's probably others, but those are the two that you're going to encounter the most often, is trapezoid and triangle, and rectangle. Though, by far, I would say probably 80% of your prisms are rectangular, probably 17% of them are triangular, and the other 3% are other weird shapes. And oftentimes when it comes down to other weird shapes, you just they have to give you the area of the base because they know you don't have a formula for finding the area of a hexagon, for example. Just the way it is. Okay? And if you did, that's another one of those ones like everybody should know how to find the area of a triangle. Everybody should know how to find the area of a rectangle. Hexagon, look it up. It comes up so infrequently, it's not worth memorizing. You just look it up when you absolutely need it. And oftentimes what you do is you just break it into smaller pieces anyway. Ones that you do know. All right. So that is prisms. That is surface area of prisms. Base area plus perimeter of the base times the height. Right? These are your two bases. These are the rest of your sides. If you're, obviously, since it was when it was a triangle, there were three. You know, just perimeter depends on how many sides you have. All right? Okay. So next up will be surface area of cylinders.